So the problem I had the most trouble with on test 3 was definitely the first problem relating to VPython. So part A asks you to add statements to calculate FNet on the craft. So what I did was, on the test, was pcraft divided by delta t, which is not what you're supposed to do because then it doesn't update. So what you want to do first is calculate r, which is the distance between the two, the craft and the planet. So you do craft.pose minus sun.pose. That's the distance between the two. Here you want to calculate the magnitude of f, which is the equation you know, but make sure syntax is very important because you want to do the magnitude of r up here. Otherwise it'll be a vector, and fmag you don't want to be a vector. But here, fnet, you want to make this a vector, which is why you do fmag times norm of r. Norm is like the unit vector, so that makes this a vector. So part B is asking you to update the position of the craft. So pcraft is pcraft plus fnet delta t. That's the momentum. So you're updating the momentum here and saving the pcraft in another variable called pfinal, which we'll use later. So your craft.pose is the initial position you had plus the updated, with the updated pcraft, you find that velocity and multiply it by time. That adds more position. So part C is asking you to calculate K, U, and E for the craft. So for K, you want, again, the magnitude of the momentum, so it's not a vector. So you square the momentum and divide by 2 times the mass. For U, again, same equation on the equation sheet. Make sure it's the magnitude of r, so it's not a vector. So negative g m craft m sun divided by magnitude of r. And then E, obviously the total energy would just be these two variables added together. So the final step of this problem is to calculate the parallel and perpendicular components of the force acting on the craft. So this is the one that caused me the most trouble. Fnet tangent, you want the magnitude of P final, which is the variable you saved up here that was the P craft. So the magnitude of that, so it's not a vector, minus the magnitude of P in it. Now P in it was given to you initially in the problem, and that value is the magnitude of P craft. So you're just calling back that variable in here, multiplying it by the unit vector of the momentum divided by delta t. So this overall will give you a vector. And then to calculate the fnet perpendicular, you just have to take the fnet you calculated up here and then subtract the tangent to get fnet perpendicular, because the perpendicular force plus the parallel force is always equal to the total force. So the most important thing to remember this problem is 100% syntax, because I think a lot of people could mess up between the magnitude r and the norm of r, things like that. So make sure you know when it needs to be a vector and when it needs to be a scalar.